What's up, guys? Welcome to the section on talking about the API functions for dumping data. The previous video was about loading your data, so definitely recommend checking that out if you haven't watched it, just to understand how to load data. But now we're going to talk about dumping or writing data to a file, and even a string. Now, the first one we're going to go over, which is probably the most common one you're going to use, is the dump function. Let's go ahead and write that out. And we'll actually go over a few lines. You'll see why. We'll just do maci.dump. And if we hover over this function, you see it actually takes two positional arguments by default. And the first one is a file, and the second one is your actual data. And if you notice, it actually takes three different kinds of data that it natively knows how to parse down and write to a file properly. And when I say write to a file properly, the dump function is designed to properly format and structure the data in a maci loadable way or parsable way. That way, if you want to reload your data, you can simply just use the load function. And as you notice, it accepts either a maci data object, a dictionary, and a class object. If you're not sure what the class object means, again, watch the load video. And that kind of talks about it a little bit. But we are going to go over each one of those options in this video and get an idea of what's actually happening. So let's go ahead and create some data and create our file. Now I'm going to go ahead and start building out our data using a maci data object. And we're going to use the data examples that we've been using from our mygame.save file. And I just added the extension .back for backup because I don't want to actually modify this file. But we are going to use a few of these attributes as an example and bring them over here in our Python file. Now I'm going to manually show you how to build out that data, but it is going to be kind of copy and pasted. If you want to get a more detailed understanding of building out your data, that's demonstrated in the object section of this series, talking about the maci object. So let's go ahead and create a variable called file name, and we'll call it mygame.save. Next, what we need to do is get our data. So let's go ahead and generate some data here. The way we're going to do it first, like I said, is using a maci data object. So let's create an empty maci data object. Call this maci data. We'll just say maci.build, which allows me to create an empty maci data object. And now we're going to start building out our data. Now this is talked about in the previous load video, if you want to understand what build is doing. So I'm going to go ahead and paste what I copied here. And I'm going to have to get rid of these for now, because obviously Python doesn't understand that. So we're going to go ahead and create that. And now what I want to do, though, is I need to create attributes on my object in order to set these. So I'm going to go ahead and prepend all these variables with my maci data variable, and go ahead and create these values attached to my maci data object. So all I simply need to do is just type maci_data dot. And if you understand in an object to create an attribute, all you need to do is use the dot notation in order to create it. Again, this is more explained in the object video. But now we have our data created. And so now all I want to do for the sake of this example is to dump it to a file. So let's go ahead and do so. So we'll take our dump function, we'll take our file name variable, and then we'll take our data, which is just maci_data. And that's all you need to do to create a file and dump existing maci data to that file. So let's run it. So we don't have a file called mygame.save only, so this is going to create a brand new file for us. So here we go. I'm going to run it. And you see a new file was created. Go ahead and close this. Let's go ahead and check it out. So look inside here. There's our data. In fact, it's an exact representation of what we had in our backup. Of course, we don't have the comment. And I think I mentioned this before in the load section or the language sections, the comments don't get retained, but there is ways to create that ahead of time. No big deal. But if we were to kind of look side by side, we move this over, you can see the data looks exactly the same. Of course, it doesn't have the lock glyphs on there, but we'll talk about that later. So there's our data. And of course, using the load function, you can load this back in at any time, whatever you want to do. Now, there's so many different things you can do, which we'll talk about in the object section, talking about the different features like how to lock, how to reference. And once you get to that section, you'll see that the dump function knows how to retain the state of the attributes in the correct format. Now, since we're already here talking about that, I decided I'll go ahead and just quickly demonstrate to you, like if we were to load the file in and then dump it back out, the comment will be stripped, but you will see the retention of the locking mechanics. So let's go ahead and do that real quick, and then we'll move on. So let's just pay attention to the top part here. So instead of building out this data, and let me go ahead and bring this file over as well. We're basically going to be updating this file, right? So I guess I don't need to keep this one open, but you see money and items have the lock glyphs on them. So let's go ahead and close that. Just remember, money and items have the lock glyphs on them. Currently, these are not in a lock state right now for this new file, but let's go ahead and load the original file, and then we'll dump it back out into this file. And then all we need to do in order to load our file up is we'll go ahead and, what is it, mygame.save.back. We're going to go ahead and load that file from the backup, and then we're going to dump a brand new file with the existing data from the other file to the new file, which is mygame.save. And remember, this returns a maci data object, so this should recognize it from the dump function, no problem. Let's go ahead and run this, and we'll see it update. So I just ran it, and you see that it updated, and it went ahead and retained the same glyph states, so we know that these attribute names are still going to remain locked. It also retained the other ones, which is this one was hard locked, and this one was map hard locked. Again, watch the language section to understand the glyphs a little bit more, but watch the object section if you want to understand how to do this in code and watch it actually get retained in the file. All right. So let's move on to the next type of data structure that we can build out that maci knows how to parse natively and dump to a file, and that's dictionaries. So I'm going to go ahead and write out the same data we were working with before using the maci data object and express it as a dictionary. Okay, so I went ahead and created the dictionary data based on the example we've been using so far. And as you can see, it should be the same exact values, the same exact names. And so let's go ahead and open up our mygame.save. We're going to drag that over. And we'll go ahead and erase this just to give a full example. But when we run this, this is going to process the dictionary data and express it the exact same way that we just saw in this file. So let's go ahead and run it and give it a go. So I'm going to run it. And there we go. And as you can see, we see the exact same names and value pairs exactly expressed in a maci structured format, which again is Python styled, but we used a dictionary set of data in order to dump it to a file. And as you can imagine, the top level key name is going to be the attribute names that get created as the actual variable names or attribute names inside of the file. So that's something important to keep in mind when dumping your dictionary data. And again, if you've seen the load video before, you can easily load this data back in. You can even load it back as a dictionary if you use the load dict function for maci. That's how simple it is to dump your dictionary data. Now I want to go ahead and demonstrate to you how to dump your custom class object data or your custom object that you create and dump it to a file. We're still going to use the same examples here, which is the name value pairs, but now we're going to do it in the context of a custom object. Okay, so I went ahead and created a simple custom object that has some instance attributes using the same exact names and values that we're using in this example so far. And I went ahead and instantiated it, just called it custom obj, and we're going to just go ahead and dump that data to a file, and it should be represented exactly like you see it here. So let me go ahead and erase this again in this file and go ahead and demonstrate that. So let me go ahead and run this. And there you go. You see the instance attributes that you had with all your values and names were exactly represented inside of this file and stored exactly like we expected. Now, again, if you remember from the load video section, you can actually load this data back into your custom object using the load adders function, which makes it conveniently useful to load your data, especially after saving it to a file using the dump function. So that's it. Those are the 3 different ways you can natively dump your data using the maci dump function, whether it be a maci data object, which has features built into it, or a regular dictionary, or if you have a custom class object or custom object that you want to dump data from to a file. All right, so now we're going to go ahead and dive into all the different parameter options that exist for the dump function. And there's quite a lot, but each one has a reason. The first ones I definitely recommend sticking around to kind of review. The later ones, which talk about like the private attributes and everything, you don't have to stick around for if you don't really need it, but if you do, definitely watch that. So the first one I want to talk about, and let's go ahead and hover over this, is appending. And if you already understand what that means, we're simply just appending data to an existing file instead of creating a new one. Now, if you haven't guessed already, when you use the dump function, it's going to create a new file every time. So if a file already exists, it's going to overwrite it. And that's something to keep in mind. But if you want to append data to an existing file, you can go ahead and use the append switch in order to do this. And something to keep note is the append switch does not work if the file doesn't exist. If the file does not exist, you will get an exception thrown telling you that the file doesn't exist. Now I'm going to go ahead to continue our demonstration. I'm going to switch back to using a maci data object. Okay, so we're back to using our maci data object, and we've just simply built out the same exact data that we've been working with. And so now let's go ahead and explore append. So if I simply just go ahead and turn on appending mode, we should actually see the data get appended to this file. So if I run this, we see the exact same set of data being appended to the file, which may not be particularly useful. And this would actually throw an exception if you tried to load this in because there's existing names already written in here. If you're not sure what I mean on that, go ahead and watch the load section video. As you can see, it simply appended the data to the file and it's there. Now, there's obviously all kinds of different ways you can append your data. I'm going to show a quick example. Let's say you just wanted like a quick new line. We have to use, for the dump function, we have to use a dictionary, a maci data object. So you can have a completely different maci data object if you wanted to that had different data in it, or you can have another custom object you want with have different data in it to append to the file. But for this example, I'm just going to create a quick dictionary of our data, and I'm just going to put, something like new. I guess I don't have to do a underscore. Yeah, we'll just call it new data, and that's it. So we're throwing a dictionary in there with new data. This should create the name, and this should give you the value. So if I run this, we're appending to the file. We should see that new, I should have called it something else, like new data or something. Let me rerun that. You'll see that gets created there. But yeah, so we see new data gets appended to the file, but we have the new name and value pair there. No big deal. That was pretty easy to use. So you can easily, again, like get a whole dictionary of data and append it to an existing file if you want to. But that's append mode. Really straightforward to use. Again, if you don't have it enabled, which is disabled by default, this will create a brand new file. So let's just say we leave this here actually. And you see it's going to create a brand new file. It'll overwrite the existing file with the new data. So that's something to keep in mind. You can undo this, get rid of this. And now let's check out the next option to explore, which is indentation. So we have what's called indent level and indentation on. Hopefully these make sense, but we're going to demonstrate them anyway. So let's move back to the original data we were working with, and we're just going to allow it to overwrite. It doesn't matter. But let's talk about the indent level. So let's start with that one. And by default, the indentation level is set to 1. Now, this is mentioned in the documentation, but each indent level represents 4 spaces, or a normal tabulation within Python, which is recommended to have 4 spaces. And it's actually a true 4 spaces. So each level represents a set of 4 spaces for each line in the structured data. And when I talk about structured data, we're talking about lists, sets, tuples, and dictionaries. So if I set this level to 0, let's go and demonstrate this. If I set this to 0, you're going to see the data has 0 indentation, right? Or 0 levels of indentation. If I set it back to 1, you see it has 1 tabulation, which is on by default. And if I set it to 2, it's going to add another 4 spaces, which is 8 spaces. So you can keep going to whatever your heart's content, but the default is 1, which seems to be the normal industry standard that you would expect. Now let me go ahead and add like a nested data structure in here. So let me go ahead and go in between this, and we'll just add like another list. We'll just do 1, 2, 3. We'll add our comma there. And so when this gets dumped, you're going to see the indentation gets continued even in the nested data structures. So if I run this, there's the nested data structure. You see now it has another indent level for all the values. So that's indent level. Now if we switch to the other indentation on, which is on by default, this simply just allows you to disable indentation entirely. So now if we run this, you'll see indentation is not used at all. And that may be desirable. You know, you may want to represent your data in line like that. So if you hate the indentation, you can simply turn it off. But by default, it's on because generally most people who express their structured data like to have it represented over multiple lines like this, just so it's a little bit more human legible. Especially if you have massive data sets that are really large, it makes it a lot easier to represent it over multiple lines. All right, so now I want to talk about multi-line string. So there's another switch called multi-line string. So it allows you to write your strings over multiple lines using the same Python-styled structure of, triple quotes to write multi-line strings. Now you might have noticed this is off by default. And the reason why it's off is because it would be more desirable, typically it's more desirable for a developer to have the string data in its original representation, as this feature does add 1 leading and 1 trailing new line character to the string, but it does not tamper with the original data in between, so that is important to understand, but it does add a leading and trailing new line character in order to create the multi-line string feature. Now something to keep note, when you use the load function, the load function doesn't tamper with the strings at all. It just reads it as is. So if you already have a multi-line string in your file, it's just going to read it as is and retain all the new line characters in there. All right, so let me go ahead and create our multi-line string. So I'm going to do maci data dot, we'll just call it like multi-string. I'm going to create our multi-line string in Python. We'll just do data 1, data 2, and data 3. And this is just representing each line. We're going to escape the first new line character because that's typically what I like to do in Python for writing multi-line strings. But let's go ahead and see what I'm talking about when it comes to dumping this data. Now, if I were to dump this data now, you're not going to see it represented over multiple lines inside of this file. So let's go ahead and do that. And you'll see what I mean. And so now when you take a look here, we escaped the first new line character. Let me go ahead and just remove that just to see what I'm talking about. Yeah. Okay. Anyways, so what's happening is that it's writing and representing your data in line. So your entire string is in line, even though there's new line characters in there. Again, the developer may want the original representation of the string data, which is typically desired. However, if you do want it to be represented over multiple lines inside of the file, because maybe it's really large and you want it to be more human legible and you don't care about the leading and trailing new line characters, you can simply enable this feature. Just search for multi-line string and just enable it. So what's going to happen is this feature is a global setting. It's going to search for any values that contain new line characters in it and create them and represent them as multi-line strings. So every single new line character, just to understand what's happening under the hood, is treated as a terminating operator, and it's going to set your data over the next line. So that's something to keep in mind. So now if I run this, you see now my data is represented as a multi-line string running over every line. Now, even though I'm escaping the first new line character, that's just for my own desire. Regardless of that, it's going to insert, again, a leading and trailing new line character to represent and structure the format of this multi-line string properly. That way, when you go to load the data back in, the syntax will be correct. But that's exactly how you would want to do it if you want to represent multi-line strings. And of course, if you make, pieces of data like this should still be represented the same. No big deal. But the main terminating operator to remember is that every single new line character is going to be telling maci to dump each line over the next line. But hopefully that makes sense, but that's exactly how you would be able to write a multi-line string value to the file. So now let's go ahead and check out the other parameter options, which is pretty extensive, but I'm going to create a new example using a custom class object to example all these custom options. Okay, so I've gone ahead and set up my basic class object here, or custom object data here. And we have a class attribute that's called CLS name1 for data1, and then we have our instance attribute here, which is called inst name1 equals data1. And what I'm going to show you is all these options affect the different behavior of your custom object and how you're able to dump the attribute names. And one quick thing I wanted to mention too is we're not going over encoding, because if you understand what that is, you pretty much know what to do with it. This was also mentioned in the load video section, but we are going to skip showing that because it's not necessary, and we're going to go straight to the other options. So before we talk about the private ones, let's talk about the class attributes. But before we talk about the class attributes, let's just quickly show what happens natively. So when you dump your custom object data using the dump function here, as we saw in the other example, and run it, and you see it's going to dump your data. But you may have noticed something here, is this object is only writing whatever instance attributes are available. And so that is the default behavior, because typically, by practice, it's only desired to get the instance attributes, which is where the true values and state changes happen in your object. But with that said, you can actually store class attributes as well. All you need to do is enable the class adders. This parameter option will allow you to store both now. So now when you run this, you're going to see the class attribute names and the instance attribute names being stored. Now you may have also noticed that comments were thrown in there. And these are helpful comments. Again, these do not get parsed when you're loading the data back in, but these are mostly just helpful comments for you to understand which ones were actually the class attributes and which ones were the instance attributes that were stored. And when the dump function is writing class attributes and instance attributes to the file, it's always going to write the class ones first and then the instance ones after. So just keep that in mind. Let's go ahead and talk about the private attributes. We're actually going to remove the class attribute switch for now, but then we're going to talk about the private attribute switch, which is the next one on the list here. So let's go ahead and enable that. Whoops. Go ahead and enable that. Now, if you don't know what private attributes are, that's just kind of an industry convention name that people recognize and understand, at least within Python, is that a private attribute is usually indicated with a beginning with a leading single underscore. And sometimes people refer to the double underscore or dunder as a private attribute as well, or private name, I should say. Now, the dump function has the ability to dump those as well, but by default it does not, and for good reason. And because more than likely the developer probably doesn't want to expose those values and have it written to a file. But if you did want to store the private attributes, the API does expose the ability for you to do so. So let me go ahead and actually disable this, which is disabled by default. And then we'll go ahead and add another instance attribute. We're going to call it name2, but we're going to go ahead and make it private with a single underscore. And we'll just call this data2. Now watch when I run this, the class attributes are not going to be written, only the instance attributes. So watch when I run this, currently private is disabled. We're still only going to get the instance attributes. We're not going to get any of the private ones. And that's very important to remember. But as soon as I enable this, oops, and run it, now you see the private attributes getting stored. Now, when I run, let me create another one here. And we're going to create a dunder one, which is double underscore, and we're going to call it name3, data3. And now when I run this, you actually see, and you do have access to the double underscore attribute names as well. Now, you may have wondered, why is that possible? I thought it was only going to give me the single ones. So there's 3 different switches available. There's private adders, which is a global switch that's going to collect all single underscore and all double underscore attribute names. But as you can see right underneath, you can actually specify which ones you actually want. So you can specify adders only or double underscore adders only, which is also called dunder, just to keep it easy. So instead, we can actually just say, you know what, I just want the under ones only. So now if you run this, you see the double underscore ones disappeared or it doesn't get written. And so that allows you to easily exclude those. Or if you add D for dunder, you can just get the dunder ones only if you want to get the dunder ones, and that excludes the single underscore. But remember, this is a global switch. So if you can think about it, this would also affect the class ones. So let's go ahead and add those. So I quickly created the class attributes as well. Now if I run this, you're still only going to see the instance attributes. But remember, you need to enable a class attribute switch in order to grab those, because those are not typically grabbed. And so now when I run this, the global switch is going to go ahead and write both. We're going to see the class attributes and the instance attributes individually, but we're also collecting the private underscore and the private double underscore attributes from the class attributes and instance attributes as well. And same thing applies if you just supply the global switch for private under only. That'll happen for both the class and the instance. So if I run this, you see only the single underscore gets written for both. And of course, dunder, only the double underscore gets written for both. So now let's talk about some of the other options. This is where it gets even more flexible. And you can actually specify if you just want the instance attributes only versus the class. So the ones we've been using is a global switch for both the class and the instance attributes. But let's say you're trying to capture the class and the instance attributes, but you only want specific settings to be captured. So you can come in here and say, I want the class attributes and the instance attributes, but I also want the private attributes of the instance attributes, but I don't want the class private attributes. So you can come in here and just say, private init adders only. And so when you run this, you see only the private ones get stored and not the class ones. So that might be very desirable for you if you still want the private ones from the instance attributes, but not the class ones. By the same token, you can also do the class. And so if I run this, you see only the class ones get stored and not the instance ones. Hopefully that makes sense so far. Well, that allows you to switch between the two. Now, this is still a global switch. This is a global switch for the class attributes. And then the other one is a global switch for the instance attributes. So if we come down here, you can also just capture the class under attributes and dunder attributes only. So if I add under here, this would only give me the single under, while still getting the instance attributes, we'd only get the single underscore and omit the double underscore, and vice versa, if we want to write it that way. Now, again, this is also available for instance attributes. We can just get the dunder for the instance, or the single under for the instance. And so you can really customize which ones you want. You can even add the other parameter option to get the dunder class attributes. So you only get the dunder class attributes and the single under instance attributes if you want to write it that way. But the flexibility is there to customize the way you want to store your data. And that was the reason for it. But that's pretty much it in terms of the different parameter switches for private attributes and even the class attributes. Probably going to kill me for saying the word attributes so much. But let's go ahead and move on to the last option, and then we'll move on to the next function. Something I almost forgot to mention that I do need to address is that when these are stored to a file and then loaded back in, the instance attributes will be loaded as is and as you would normally expect, but the class attributes are not going to be injected into the class. They're actually going to be loaded as instance attributes. So that's something to keep in mind. But if anything, it is a helpful utility if you need to store your class attributes to have a reference of them. On a side note, there is a desire down the line to add the ability to create class attributes loaded back as class attributes in the file, but that feature is not yet available, but hopefully down the line. Okay, so I've gone ahead and changed our settings back to the original data names and values that we were using in our earlier examples. And for this last parameter option, this is going to demonstrate kind of a forwarded feature that got forwarded from the previous library, which I'm not going to go into. But if you hover over here and you see use symbol glyphs, this is mentioned in the documentation in the language section if you want to understand what the symbol glyphs are. But as you notice, it's actually off by default. And that's because it's an old feature, it's still supported, but it's not recommended to use anymore. But I'm going to show it anyway. So if we enable the use symbol glyphs, well, before I do that, let me show you the new glyphs are represented like this. You see this plus L equals 1000. That is saying lock. This is saying lock. And we can maybe update this one to do H, but that's saying hard lock, right? And if you're not sure what I'm talking about, please watch the language section to understand further. That's the modern glyph style recognized in maci and recommended to use. It's also a little bit more understood on what you're doing. However, if you want to use the original symbol glyphs, that's totally available. And if you just activate it and say true, what's going to happen is maci's load function will natively read either the modern ones or the old symbol ones. Either way, it doesn't need any special switch to understand that. But the write mechanics of the dump function does need to turn on the switch in order to write it that way. So let me go ahead and run it and you'll see what I mean. So now you see the symbol glyphs, they got completely changed. This is the original functionality that was ported from the original library. Again, I'm not going to go into deep detail about it, but this is also supported if you wanted to do so. But again, natively, that's not recommended, and the dump function already natively understands that, so it's best to use the modern practice and not the old one. So that concludes the dump function from maci, which has a lot in it, but the next one we're going to jump into is the dump raw function. And if you haven't seen the load section, that talks about loading raw data, but now we're going to talk about dumping raw data. So I'm going to go ahead and remove this. And we'll go ahead and just create like a simple string, my string data. And we're going to go ahead and enable now the dump raw function. Here's our dump raw function. First positional parameter is the file name. And then the second one is any data. And when I say any data, you can put in any data because all it's doing is taking your raw data and writing it to a file. So this is more of like a utility function, kind of like with load raw, where it makes it a lot easier to read and write data to files instead of re-implementing file handling functions or methods, whatever you want to do. This takes repetitive code implementation and just makes it straightforward. So remember, this is not going to append, this is going to write over, so I'm going to create a new file essentially. And so there's my string data, right? So I ran that, there's my string data. If I create a list, it's going to write it raw. It's literally just writing it raw to a file, no special formatting, completely raw. And of course you can append on there. So jumping into the next options, which is append, you can simply append if you need to just quickly append data to a file. Again, this is a very helpful function to just simply write data to a file. Now, the next option as well also supports byte data. So if you are writing byte data to a file, you just need to explicitly define that. It's just simply true. And of course, I need to convert my object to a byte data. So you see how it complains, it's expecting you to be using byte data. I'm gonna go ahead and do that and run it. And now it gets sent as byte data. But if you understand what byte data is, again, the load function also supports, or load raw, I should say, supports loading byte data back in as well. So the next option I want to go over is the new line separator. So the new line separator is on by default, and this has to do with adding multiple chunks of data within the function. So let me go ahead and remove all this. An example of what I'm talking about. So we'll just say like data1. And we write that normally, and we see that as a string in there. No big deal, as the raw data of the string in there. However, if we wanted to add, as you can see, there's an asterisk here, which means we can put in an unlimited number of positional arguments. If we add another set of data in here, and I guess it could actually be anything, right? It could be a list. So let's add a list in here. We're going to also run that. So if I run that, what's happening is the new line separator is saying for every argument inside of this section here, it's going to add a new line separation so it can separate your data automatically. And that may be desirable because you may not want it all in one line, like represented like this. Your first thought might be, and natural thought might be, is, for every piece of data chunk that I add in here, it's going to automatically separate out every single chunk of data. And your chunks of data might be massive, right? But that's what it does inherently, and of course you can disable that if you don't desire that. So we'll just say false and set that to false and see what happens, and it does exactly what I just mentioned. But it's on by default because that's kind of the natural expectancy you might think when first approaching this and you're adding a ton of chunks of data. It will separate them on new lines automatically for you. Now, the last option, again, is encoding. If you know what encoding is, I'm not going to go over that at all. But again, that's just for encoding formats, and the load raw function also supports that, depending on how you've encoded your data. But I'm not going to get into that. All right, so let's go ahead and move on to the dump string function, which will be the last function for all the maci API functions, aside from the tooling functions, which will be mentioned in a later video part of the series. And dump string, if you're familiar with that concept already, doesn't take any kind of file path because it has nothing to do with files. But dump string is just like dump, but it's returning the data, as you can guess, in the format of a string. And so the data is returned as a string, and of course it accepts maci data object, dictionary, and class object. If you're not familiar with what I'm talking about, please watch the dump section, which goes over all of this. But for now, I'm just going to go ahead and put in a dictionary. I'm not going to go over all these options because we already went over that in the dump section. And I'm just going to demonstrate what's being returned and printed to the screen. So let's go ahead and drop the file name. And we're just going to use a dictionary. And I'm just going to say new data. And we're just going to say data1. That's totally fine. And so what should happen is this should return a string, but in the format that's structured for maci. So I'm going to close this because we don't need to show that anymore. And we're just going to return, oops, we're going to call this maci string because the string is being formatted in the maci format. And then we'll just go ahead and simply print it so we can see what I'm talking about. And so now if we run this, you see our string gets printed to the screen. And just like you would expect inside of the file, you see the attribute name equals and then the actual value. And so you actually see that the original representation of the string is being maintained. And if you wanted to carry your maci data in the format of a string, this is one way on how you can do this. And again, you can take like a whole maci data object and convert it to a string. In fact, if we were to load, let's actually go ahead and do this. If we were to load our original file which was what the my game. So it's my game dot save dot backup. All right, if we were to load this original data, we can actually go ahead and convert our original data into a string. So we're to take our maci data, and now if we were to run this should print all of our data that's inside of the file, right? So if you look at this is a string representation of everything inside of the file, right? If we open this file just to review, you can see that. Obviously, you don't see the comment because we're not loading the file raw, right? We're just loading the object in, which is going to ignore comments. And then that's going to go ahead, like you see, be shown in a string format. Here's actually a good example right here of the multi-line string. You see this is still represented in line, but inside the file, it's actually represented over multiple lines, right? So how do you actually maintain that? And one way we can do that, just like we've seen in the dump, again, is just to enable the multi-line string mode. So now if we run this, you see the multi-line string actually gets maintained inside of the string. So that's how you can convert or dump your data to a string, depending on the option you pick. Again, it's going to be a maci data object, a dictionary, or your class object. Please watch the dump part of this video to understand all the differences and all the different options available here to you that you can utilize. And that's it. That's going to go ahead and wrap up the dump section of maci from the API functions, and that's going to wrap up the API functions in general. Again, there's more tooling functions you can use, but that's described later in this series. Thank you so much for watching. Hopefully this was helpful to you, and take care.